So in the last section, we looked at measure of centrality, average or mean, median, and mode. And now we're going to look at measures of dispersion. So this is how, where's the center of the data? This is how spread out the data is. And for this purpose, we're going to start with a simple case study, which you can practice when you do an assignment. You can work on this in Excel to get a better feel for it. But I'm just going to talk through it. So here we have two sets of data for student grades in Uni A. So if you look at the table on the right hand side, the first column is University A grades and the second column is University B grades. Now, these two data sets have got the same average. So the average grade or average mark in both of them is 45. If you look at the histograms, you'll see the way the data is spread out in a histogram, which is the graphical representation of a frequency table, right? Now, not only is the average the same, but if you look at the two charts, so the left-hand chart is the histogram for Uni A and the right-hand chart is the histogram for Uni B. You can see they also, using those bins, they also have the same mode. So in the left-hand chart, the highest column or the most frequent data set is 45, the 45 to 50s, and in the right-hand one, Uni B, the most frequent, the highest column is 45 to 50s. So this is important. If you calculate the mode directly off the data, like the columns on the right, you'll get a certain answer. But you can also do a modal calculation where you just calculate it directly from a chart. So you're not looking at individual data items, you're looking at a band. But it's the same, it's 45 for each of them. Now, the next thing you can also calculate roughly from the chart is you can work out the median. The median is the centerpiece of data. So if you look at the left-hand column, left-hand chart, the histogram, you can see there's 1, 2, 3, 4, 5, 6, 7, 8, 9 bars. So it happens to have 9 bins. So that means the middle bin is going to be number 5, which is the 45 bin. So 45 in the left-hand data set for Uni A is the median and the mean and the mode, right? Now for the right-hand data set, you can see there's only 6 columns because it's not as widely spread. So that means the median figure is somewhere between the third and the fourth. So the median there would be somewhere between the 45 and the 50 column. So that means the two data sets have got the exact same mean, they've got the exact same mode, and they've got a very similar median. So they look very similar when you're looking at measures of centrality. But we want to see how spread out the data sets are. And you can see straight away by looking at the charts that the left-hand data set, Uni A, is more spread out because some of the data in the left-hand data set is in the 20s and in the 30s. And some of the data in the left-hand chart is in the 60s, over 65. So there's some students there's quite a few students who score very low and very high. If you look at the right-hand data set, Uni B, the data is much more squashed in the center. That means there's nobody scoring in the 20s, there's nobody scoring in the low 30s, there's nobody scoring over 65. Everybody squashed in the center, and that's reflected in the ogive, the orange. You can see how the ogive for the right-hand data has nothing on the left and nothing on the right. It just climbs steeply in the middle. So a histogram gives us immediately a visual representation of how dispersed the data is. So look, we want you to build those histograms yourself in the assignment and make a comment on the data. In the previous example, we looked at measures of dispersion just visually by looking at a chart and making comments about it. Now we want to do computations and calculate measures of dispersion. So we get an exact number for each measure. So there's different measures of dispersion. The simple one is range, which is the maximum by the minimum. So you'll see that the bigger the gap between maximum and minimum, the larger the range and more dispersed the data is. The other measure is the variance or standard deviation, which are two parts of the same calculation, and that's a more precise measure than range. It's much more reliable. So let's take a look at this data. We've got data set which will be given to you in another assignment, and you'll be doing calculations in this assignment. So you've got students and you've got scores for them. We want to get an exact score for a measure for the dispersion of this student data set. So here's the formula here, and this is the detailed formula for calculating both the variance and the standard deviation. So you'll be able to do this automatically in Excel, but we want to do it in this exercise, calculate it manually just to get get the feel for the way that these things are calculated. So if you look at the data, that formula at the top, there's an expression which is over the horizontal bar. Sum of n I equals I, open brackets xi to x bar, close brackets squared. And that's over n minus 1. So that whole expression inside the square root is called the variance. So what those terms mean is n is the number of data points in the data set, xi is each of the values of the data. So if you look to the left, it just simply means that Michelle scores 80, so that's x1. Ryan scores 77, so 77 is x2, all the way down to say x10. And x bar is the mean of xi. So the mean of all of those numbers is x bar. Remember that x bar is the term for the mean when it's a sample, and mu is the mean for the population. So if the sample is the whole population, they're the same answer. So when we calculate the standard deviation, Sx, S of x, it's very useful because if the data is normally distributed, if you see that chart at the bottom right there, normally distributed means the data has a central peak and is evenly spread out on both sides. In every case, for normal distribution, the data will be 68% of the data will be one standard deviation either side of the center. 95% of the data will be two standard deviations either side of the data, and 99.7 or all of the data will be three standard deviations either side of the data. So when you say something has a standard deviation of 1 or 1.2, it means a lot. So what you want to do in the assignment is actually do the calculation. So you can see there we've got a spreadsheet, and you've got the start of the spreadsheet provided to you, and you simply have to finish them off. All you have to do is complete columns C and D by putting in formulas, and Excel will do the calculations for you. And you need to then, at the bottom of the table, use those totals and calculate the standard deviation manually, right? So you can see there, let's take the example of first row data is a student with a score of 82. And you can see that the first term inside the brackets in your formula is xi minus x bar. So we want to calculate the difference between each score and the mean. Now you notice in this example here in the beige box, the mean is using the term mu, whereas in my text it's x bar. So x bar for the sample, and mu for the population because we're taking all of the data here. So they're the same basically. So the difference between the first score and the mean is 82 minus 79, which is 3. And then we square that to get 9, and that gives us the square of the difference. And for the next score of 77 marks, the difference between that and the mean is 77 minus 79, so it's minus 2. That means the first data point was 3 above the mean, and the second data point is 2 below the mean. And then on the far right hand side, you see we square them. And the reason we're squaring them is we want to get the absolute amount of the difference. I don't want to know how much everything differs from the mean, because that always sums up to 0 for all the data. I want to know the absolute amount. So we square it to get rid of minuses. At the very bottom there of column D, you'll have the sum of all the squares of the differences. So that's the same term as you see in the calculation. And then the second column C, we've also got the sum of all the deviations about the mean. So the squared deviations about the mean is what we want for our calculation. And all we do is, that's the top of the variance calculation, and then all we do is divide that by n minus 1 and square root it again. And square rooting it reverses the squaring and gets us back to a proper scale. So the variance is an accurate score, but it's not in the same scale as the actual raw data. So we can see our raw data here, the student scores. They run student scores can only be between 0 and 100, but in practice you can see that the student scores are all between things like 60 and 90. So the thing about squaring and square rooting back to the standard deviation is the standard deviation will be in the same scale as the raw data. So it makes sense. So you might have a standard deviation of 5 or 2 from the center for data that's only 66 to 82. So try that calculation and see what you get for that in the Excel exercise. So having calculated the standard deviation manually, just as a practice exercise, you can of course calculate it automatically in Excel. The two ways to calculate are you can just put in the standard deviation function, just the same as you put in an average or mode, or median function, or you can calculate the full descriptive statistics for any data set, which includes standard deviation. So to calculate the full descriptive, so you can see here in my example of the data, in column A we have the actual data set, and in column C and D we have the descriptive statistics. So in order to calculate descriptive statistics, you must choose the data analysis command from the analysis tab on the data menu. Now, the analysis tab is not in pre-built Excel. You have to install it, and that's something you did already for exercise 7C. So if you haven't done exercise 7C, or you want to review it, go back and look at the instructions for that. That'll give you the data analysis tab. In that exercise, we calculated a histogram from using the data analysis commands. Now we're going to calculate descriptive statistics. So the only thing to remember is when you get the descriptive statistics option, it asks you, do you want to group the data by rows? That means it's all in one row, but this is all in one column, so you want to select the grouped by columns option. And the important thing to remember is the difference between a population standard deviation and a sample standard deviation. They're not always they're not necessarily the same. So if you look at this case here, you can see in the Excel descriptive statistics, in cell D8, it gives you a standard deviation of 10.35. That 10.35 differs from what you calculated manually. You should have calculated 9.82. So 9.82 is the correct population standard deviation because the 10 students we have are the entire population. However, Excel itself always assumes that the data you're giving it is a sample from a larger population, and it calculates by default the sample standard deviation, STDevS. And you can see the two calculations down below in cells B18 and B19. The Excel calculation for population deviation is 9.82, and for sample it's 10.35. So see if you can repeat that screenshot there in Excel as a short exercise. Finally, you can calculate the same summary measures in SPSS. Chapter 4 of the SPSS describes how to calculate summary measures. You can have a look at that yourself, and you can try out this little task, but there's no specific assignment and upload required. So look at Chapter 4, ignore the bit about charts. You can use the demo.save dataset. You can calculate summary statistics for selection of columns. You can select as many columns as you want and calculate in one step all the summary statistics for all those columns. So this is a simple thing that takes a few minutes. So just for yourself, pick one nominal column in the dataset, one ordinal column, one scale column, and run summary statistics for the three of them and take a look at the output. The output you generate is an SPV file, of course, but you can also export that to PDF. But take a look at that column and see if anything comes up that you want to raise in the discussion. So thank you for that.